We need the fraction to be positive. And so here are the possibilities. If we had a positive number divided by a positive number, that would be something that's greater than 0. So this is one possibility. But there are other possibilities as well. How about a negative divided by a negative? That would also make a positive number. Certain things would not work. Like, for example, if we had a positive divided by a negative, that would make a negative. And a negative divided by a positive would also make a negative. So these cannot be part of our solution set. So how do we write these statements? Well, we need to use and or in these types of problems. What we're saying here is that I need the numerator to be positive, and the denominator also needs to be positive. Over here, the possibility is that it might be that the numerator is negative and denominator is negative. So I'm breaking the problem up into different circumstances that would give us solutions. And so between these two, either one of them is a possibility. And if we meet just one of those possibilities, then we have a solution. So the word that I have to put between these two is not and, but or. Okay, let's try to write a mathematical way of saying that the numerator is positive. So our numerator was 2 minus x. I need for that to be greater than 0. And at the same time, I need the denominator to also be greater than 0. And that's just one possibility. On the other side here, we'll do negative divided by negative. I need the numerator to be a negative and the denominator to be a negative. And then always having an or between these two. Then what we want to do is solve each inequality and see what the results tell us. So let's move this 2 over. We'll get negative x is greater than negative 2. When you're dealing with inequalities, you just, in large part, do the same thing that you would do with equations. Okay, but let's just on the side here point out one difference between inequalities and equations. So if I had something like 2 minus x is greater than 0, and then compare that to what you would do with 2 minus x equals 0. For subtraction, there's really not much difference between inequalities and equations. Either way, we'd get negative x on the left and negative 2 on the right. However, when you're dividing by a negative, that's where there's a difference between inequalities and equations. So whereas for an equation, you just divide as normal and then follow the results through and get x equals 2. With an inequality, something has to be done in addition to that. When you divide by a negative, you have to switch the direction of the inequality. That's a rule of inequalities. Now, it only happens when you are introducing division or multiplication by a negative. You don't do it just because there's a negative in the problem. You know, like I'm not switching the sign because there's a negative on the 2. I'm switching the sign because I wanted to get rid of the negative on the x by introducing my own negative in the denominator, and that's when you have to switch that sign. Cool thing about inequalities is in Desmos, the app, we can graph them and see their solutions as well. Let's go to Desmos. So for something like an equation here, of 2 minus x equals 0, there turned out to be just one solution. And 2 is obviously the solution. When you type in a solution of an equation like x equals 2, you just get a vertical line. It intersects where the solution occurs at x equals 2. You could even plot the original equation and still get that solution from Desmos. So with an inequality, you can actually type in that and get your solution. But it's not just one number. It's a whole range of possibilities. Okay, but that's only part of the result. We have to solve the other guy simultaneously here. So let's subtract 1 there. And we get that x is greater than -1. There's an and between those, though. We have to find the final solution set from this result. Now, one technique for finding a solution set of like a compound result like this is to make 2 number lines. One for the left side and one for the right side there. Put any relevant numbers down on the paper. So obviously 2 and -1 are important numbers to this. Now for the x less than 2, we want to shade everything to the left of 2, but because it's not having a line underneath the inequality, we're not going to include 2 in that part of the solution. So all we want is an open dot at 2 and an arrow to the left, and that shows the numbers that meet the criteria of being less than 2. Okay, then you want to plot the other result, that x is greater than -1. And like I said, if it was having a line under it, we would actually shade in the -1, but it doesn't have that, so we're gonna have an open dot there. And now let's draw all the numbers that are greater than -1. So the mouth here opens toward the one that is greater, so all our solutions are greater than -1. Here the 2 is the greater of the 2. Alright, now at this point, that's a good start because we have both of these statements plotted. But now we have to decide how to combine them into one final result. So it makes a difference if you're doing and or when it comes to how you put together the final result. If you were doing or, then what I say is you would merge the 2 together, where as long as a number meets the criteria of one of the lines, then it's kept in the final solution set. So I want to show the difference between what I would do with and versus or on the side. Okay, so I'm going to do 2 different scenarios here. One of them is going to be involving an and. So let's say I was asked to do, x is less than 2 and x is greater than -1. That's actually what we were asked for in this part of the problem. But I just want to compare that to what I would do if it was x less than 2 or x is greater than -1. So the difference is with an or, you merge them together into one final result where you can actually bring everybody down. And as long as you're touching any solution set on either the upper or lower lines, it's kept in the final result. So for an or, we would merge them into one big line like this. And that would be your final answer. So it would basically be from -infinity to infinity, or you could say that x is between -infinity and infinity. That would be for or. For and, it is different. For an and, you only keep locations where you're crossing through both solution sets. So at 0, for example, 0 is in both solution sets, therefore it is kept in the final solution set. But these numbers to the left of -1, they would not be kept, because even though like -3, for example, is part of the upper solution set, he's not part of the lower solution set. So -3 doesn't meet both criteria. It's an and. So he would not be kept. Similarly, 3 cannot be kept, because even though it meets the criteria of being greater than -1, it is not less than 2, so it can't be kept. Our final solution set for this one then would be all the numbers between -1 and 2. That would be our final result for x less than 2 and x greater than -1. We can write that final set in interval notation, which is -1, 2, or we could do it in algebraic notation. It's between -1 and 2. Okay, my final result then for this part of the interval is going to be exactly what I found here. This is my result. Okay, now that is going to be part of my final solution for this problem. However, it is not the only part. There could be more. Or maybe we'll find out that there's no x's that will meet the criteria of these statements. I don't know yet. We'll find out by doing the math. So let's solve these. Division by negative. So switch the sign direction. Okay, I get that. And we get that, with an and between them. So now let's analyze those lines. Okay, so here are my graphs. They said that x had to be greater than 2 and x also has to be less than -1. Is it possible? Well, let's compare and versus or. So on the left, I'll examine what it would be with and then on the right, I'll do the solution set as if it was or. Okay, so the final solution set, if we're talking about or, would have been where every number that's part of either set is kept. So take -3, for example. -3 is not greater than 2, but it is less than -1, so he would be kept in the final solution set. The number 3 here is greater than 2, but it's not less than -1, but he would be kept because it's or. If we were doing or, we would be able to keep all of this stuff here. We couldn't keep 0, 0's not in either solution set. But when you write your final results for or, it would be a merging together of the two lines. So it would look like that, and like that. That would be the final result if it was a or. And then what you'd have to do is say that in interval notation, you've got an interval on the left from -infinity to -1, and then you could actually union that together with your interval from 2 to infinity. This would be the result for x greater than 2 or x less than -1. We don't have an or though, we have an and. When you have an and, like we showed previously, we can only keep regions where the number lines overlap. That would be this region here only. These x's are part of both sets, and that's why they're kept in the final set. When it came to an or, you just keep anybody. As long as you're in one of the sets, you're kept. So big difference there. Down here, I was able to keep everything to the left of -1, and I was also able to keep everything to the right of 2. However, what should I keep here? Yeah, you can't keep anything. We would say just empty set or just no solution there. And so that's what we have here for our problem. This whole side has actually no solution. Now that doesn't mean that we don't have a solution in our problem overall. This is a or between these two. So as long as numbers meet one of the criteria, left or right, they can be kept in the final solution set. So we would now put them two together into one final result. The final result is, of course, just the guy on the left. This is our final solution set. Now we can show that in Desmos that this would be the solution set. Going back to the original problem, it's a good way to check your work. What you want to do is just type in the problem exactly as it appears on the page. Very useful, this Desmos. Okay, there is the function itself. If you want to just see the function briefly, what we're looking for is places where the function is positive. So positives would be when it's above the x-axis. So this whole region here looks like it's positive. There's an asymptote though occurring at -1. And we also see that 2, x equals 2, is the location where the thing has a 0. So he's going to be positive everywhere from -1 to 2. It's true according to the graph. If you want to see that solution set graphed by Desmos, then you just type in the inequality. It's going to shade in the x values where your graph is positive.